It is my great pleasure to introduce Dr. Chris McKay, a senior NASA space scientist and world-renowned authority on Mars. Thanks.
Well, welcome everybody. What I want to do just in the few minutes that they asked me to speak about the mission is pick out the one moment which for me was the most important result, the most interesting period for the last year. So we've been on Mars, driving around for a year, rolling over rocks, zapping under blazers, scooping up dirt, and so on. So there's a lot of interesting stuff, but the one event that I think will be remembered as the most important result of the mission so far was here on these mudstones. These are rocks that were deposited, we think, billions of years ago by water. We think that because of the shape of the rocks and the fact that the materials cementing the rock is calcium sulfate, which is a water deposited salt. So we had a good reason to think that these were water deposited sediments, just the sort of thing we wanted to find on Mars. And that was where we decided to drill our first drill hole. And that's the moment, I think, that we made our most important discovery, which is that the material just below the surface. Remember, this drill can only go about an inch deep. It's not much of a drill. It's about the diameter of a dime and an inch deep. So it's something you might let your little kids play with in the backyard. It's not a serious drill, but it's the first and the deepest drill we've ever done on Mars. And it made a significant discovery, which is just beneath the surface of this red, rusty planet, there's a gray, not rusty world. And that's the world that's of interest to me in particular. My role on this mission is to be part of the teams that are searching for evidence of organics and ultimately evidence of life. And the results of this drill show us that that's the direction to go, down. Just by going an inch, we already went from this red Mars that we've seen everywhere on the planet to this gray stuff. And looking at this gray stuff, we would expect it to be one, not red. Okay, that was an easy one. We'd expect it to be reducing, not oxidizing, to have not oxidized iron, rusty iron, but more reduced materials. We'd expect it to have organic material. And we'd expect it not to have the stuff that's on the surface, like perchlorate, that interferes with our ability to detect organics. Well, that's what we expected, and we were right and we were wrong. It was reducing, and you might hear more about that later. It did not contain organics, and it did contain perchlorate, which initial results seem to indicate what that's telling us is that the processes on Mars that produce perchlorates and destroy organics are operating even in the subsurface. And I think that means they're being driven by radiation. It means we have to go deeper than an inch. We have to go several meters. Really, we'd like to go 5 meters. I think that my summary of what have we learned in a year on Mars from curiosity, we've learned that there is a subsurface Mars, and it is very different. And to find organics in that subsurface Mars, we need to go deeper than we've done so far. That to me is the conclusion so far. Now, we can't put a bigger drill on Curiosity, so we're going to go to try to find deeper by trying to find a place where there's been a landslide or a crater or some other process that's naturally dug down to deeper material. So that's what I'm hoping we'll find in the next few years as we go traveling around on Mars. Thanks.